Acid-base titration, a way of determining how much acid or base is present in solution by determining the precise volume of acid or base that will completely react with it. Purpose and application. First is used in pharmaceutical to test drug purity and dosage. Second, determine acidity of food and beverages. Third, monitors water quality and environmental pollution. Lastly, used in laboratory standardization of acid and base. Key concept and terms. Acid. Acid is a substance that produces hydrogen ions in water or donates proton in reaction. Base. Base is a substance that produces hydroxide ions in water or accept protons in reaction. Titration. Titration is an analytical technique where a solution of known concentration is added drop by drop to another solution to find the exact concentration of the unknown. Breath. Breath, a graduated glass tube with a tap at the bottom, used to measure and release precise volume of liquid during titration. Titrant. Titrant is known for solution. Analyte. Analyte is unknown solution being analyzed. Equivalence points. Equivalence points, the exact points where acid and base have completely reacted. Endpoint. Endpoint is the point where the indicator changes color. Standard solution. Standard solution is a solution with a known concentration used for titration. Primary standards. Primary standards is a highly pure compound used to prepare a standard solution. Here are the types of acid-base titration. Acid-base titration are classified based on the strength of the acid and base used. The strength refers to how completely they ionize in water. Each type produces a different pH curve and requires a suitable indicator to accurately determine the endpoint. In this picture, the pH is plotted against the volume of base that is progressively added. After that, the pH slowly rises, then sharply rises towards the equivalence point.
Hi, now let's proceed to the different acid-base theories and the scientists behind them. Let's start with the earliest one. First is Arrhenius theory. According to Sebastian Arrhenius, noong 1884, an acid is a substance that gives off hydrogen ions in water, meanwhile a base is a substance that gives off hydroxide ions. Simple lang ito. This theory only works sa aqueous solutions or solutions with water. Next theory is the Bronsted-Lowry theory. Sabi ni Bronsted, Johannes and Thomas Lowry noong 1903, sabi nila that an acid donates a proton and a base accepts a proton. Mas po dito kasi kahit walang tubig, pwede silang kumuha ng electron. Basta may proton transfer. Next is the Lewis theory by Gilbert and Lewis again in 1903. For him, an acid accepts an electron pair and a base donates an electron pair. Ginagamit ito sa mga reactions na hindi nagtungkol sa hydrogen or hydroxide. Next is Ozon-Levick theory by Mikhail Ozon-Levick noong 1938. Sabi niya, an acid is any substance na tumatanggap ng anion or electron or cation. Habang ang base naman ay kabaliktaran, nagbibigay ng electron or anion. Ito na ang pinakamalawak na definition kasi kasama na pati redox reaction. Last but not least is the Lux-Blood theory by Hermann Lux that he proposed noong 1939 at pinalawak ni Hackenflood noong 1947. He said that an acid accepts oxide ions and a base donates oxide ions. Usually, ginagamit ito sa molten salts or solid oxides, hindi sa water. Now, let's proceed to the different contributors to acid-base titrations. First is François Antoine Henri Descrazel noong 1791. He invented the first burette and performed early titrations. Next is Joseph Louis Gay-Lussac noong 1824. He developed the volumetric analysis method for acid-base titrations. Next is Jean-Baptiste Guillaume noong 1830. He improved the quantitative analysis using titration. Last but not least is the Carl Frederick Moore noong 1855. He refined the burette and developed Moore's method. In short, dahil sa kanila, nagkaroon tayo ng accurate tools and methods for acid-base titration. From this Descrazel first burette to more refined version na ginamit pa rin natin ngayon. In summary, the acid-base theories and contributors, each scientist helped us understand acid bases in different ways, from simple ion exchange to electron oxide reactions.
Now that we understand what acid-base titration is and the different types, let's move on how to actually solve titration problems. It involves using mathematical relationships between the acid and base to determine unknown concentrations, volumes, or moles. To do this, we use a very important equation called the titration formula. The basic formula is m sub 1 v sub 1 is equal to m sub 2 v sub 2. Here, m sub 1 stands for the molarity of the acid, v sub 1 is the volume of the acid, m sub 2 is the molarity of the base, and v sub 2 is the volume of the base. This equation works when the acid and base react in a 1-to-1 ratio, such as hydrochloric acid reacting with sodium hydroxide. However, when the reaction ratio is not 1-to-1, for example with tetroic acids such as sulfuric acid, we use the more general form, which is n sub 1, the n is a small letter, while m and v are uppercase. N sub 1, m sub 1, v sub 1 is equal to n sub 2, m sub 2, v sub 2, where n sub 1 and 2 represent the number of acidic hydrogens or hydroxide ions that react per molecule. This makes the equation work for all types of acid-base reactions. Here is a simple step-by-step process to solve titration problems. Step 1, write the balanced chemical equation. Step 2, identify what is given. Step 3, substitute values. Step 4, solve. And step 5, make sure to convert milliliters into liters when using molarity. So, let us start with an easy problem. It requires 75 milliliters of 0.500 molar sodium hydroxide to neutralize 165 milliliters of hydrochloric acid solution. What is the concentration of the hydrochloric acid? So we're looking for m sub 1, the molarity of hydrochloric acid. So first, of course, we substitute the values after determining what equation we want. So as you can see, we have substituted the values. After we have found the given, we are looking again for the hydrochloric acid concentration. Now, after we substitute the values, we just multiply and we isolate m sub 1, which gives us 0.227 molar. So the final answer is the hydrochloric solution has a concentration of 0.227 molar. Now, let us try a reaction that is not 1-to-1 ratio. The problem reads, how many moles of sodium hydroxide are needed to neutralize 25 milliliters of 0.200 molar sulfuric acid? First, we look at the balanced equation and determine the ratio. So, the ratio is 1 mole of sulfuric acid is to 2 moles of sodium hydroxide. Step 1, we find the moles of the acid. We write the formula with the ratio. Step 2, we find the moles of the sodium hydroxide, and step 3, we use the ratio 1:2 to find moles of sodium hydroxide. After isolating the asked variables, we have come to the final answer, which is 0.01 moles of sodium hydroxide are required to neutralize the acid. So this one is different because we have to adjust it to the ratio that we have calculated. Let us move on to the last example. Let us find the volume required for neutralization. The problem reads, what volume of 0.2 molar sodium hydroxide is needed to neutralize 25 milliliters of 0.1 molar sulfuric acid? We write down the balance equation and now we determine the formula that we will be using. So we are looking for V sub 2. Yes, that is the variable that we are looking for, so therefore that is the variable we are going to isolate. After substituting and isolating V sub 2, the final answer is 6.25 milliliters of sodium hydroxide is needed to neutralize 25 milliliters of sulfuric acid. That therefore concludes the 3 types of problems for acid-base titration. In conclusion, acid-base titration is a way of determining how much acid or base is present in solution by determining the precise volume of acid or base that will completely react with it. It has many purposes and applications in our world, for example, used in pharmaceuticals, determining acidity in food, and many others. We have discussed the individuals who have helped formulate this concept, and we have also discussed the 3 types of problems in solving acid-base titrations, in which there are 2 types of formulas to use. So that concludes our discussion for acid-base titrations. So we hope that you have learned something. That is all. Thank you.